Hello folks, it has been a while that I've actually uploaded a video. Good morning, good evening, good day, whatever time that you're watching this video. Welcome. My name is Mr. Matlabiani MS. As you already know me, your mathematics teacher. So in the previous video, we actually looked at the formula for the sum of arithmetic series, and we saw that it is actually given by this formula to say Sn is equals to n divided by 2 into 2a plus n minus 1 into d. Those of you who are new to my channel, I will actually leave a link below for the previous videos. Okay, so just check the link, and please don't forget to subscribe. Don't forget to hit that notification button so that you are notified of other videos in future that I will upload. And please leave comments so that I can improve on my presentation. Let's hop into it for today's lesson. So in this lesson, this is what I wanna talk about. We will actually focus on the relationship that exists between Tn and Sn. And remember, Tn, it means number of terms in a sequence, and Sn, it means the sum of number of terms in a sequence. Please don't make a mistake. The relationship that we're going to be talking about here will only exist provided, or if and only if, the sequence is arithmetic. Okay? I repeat, the relationship that we're going to find here, that we're going to investigate, will only be true provided the sequence is an arithmetic. So it means the relationship for Tn and Sn, for whatever findings that we'll actually have, will only be feasible, will only be valid provided the sequence is arithmetic. Okay. Now, consider the arithmetic a progression. We sometimes call it a progression. Progression, it's similar to a sequence, because when you say progression, we're looking at how numbers progress following a particular pattern. So suppose you are given the following sequence. By default, you check this word. By default, if we say it is arithmetic progression, what is the implication? The implication, it means it has a common difference. The first difference is constant. Okay, and remember, 3, we actually call it T1, 7 T2, 11 T3, 15 is T4, so on and so on, up to infinity, up to Tn. Okay, so now if we were to investigate, we must be sure that indeed this sequence is arithmetic. Okay, and then how are we going to do that? You will actually look at the difference that exists between any two consecutive or any two successive terms. So you take the succeeding term, you subtract the preceding term. So 7 minus 4, 7 minus 3 must be the same as 11 minus 7 must be the same as 15 minus 11, which is equals to 4. So it means we can confidently say this sequence is arithmetic because the first difference is common. So it has a constant difference, the first constant difference. which is 4. Okay, now it means we can easily investigate now, because I've indicated at the beginning that the relationship between Tn and Sn can only exist provided the sequence is arithmetic, and this one is arithmetic. Then it makes our job easier. Okay, now let's check. If you were to look at the sum, when you say sum, let's review a bit. Sum is the answer that you get when you add two or more numbers. Product is the answer that you get when you multiply two or more numbers. And the quotient is the answer that you get when you divide, just like that. Okay, so in this case, we are looking at the addition of two successive numbers. Okay, so if you have one term, if you were having 3 and you were supposed to add one term to itself, the answer will remain that particular term. This doesn't need a metric break. It's obvious. Sum of one term is equals to that term. So that is why we can confidently say sum of one term is equals to term number 1, which is equals to 3 in this case. Okay, but now let's check if we were actually having S2. If you look at S2, S2 will be the 2 here, it tells us number of terms that are there in the sequence. So if our sequence was having 2 terms, so it means if we were to sum the terms, it will be term 1 plus term 2, which is term 1 plus term 2, which will be 3 plus 7, which is equals to 10. Okay, so you can do the same with S3. You actually have T1 plus T2, T3, then it will give you 21. And then lastly, you can actually have S4, which is T1 plus T2 plus T3. So you add these numbers, they give you 36. Okay, so it means when you add one term, you get a 3, 2 times 10, and then 3 times it will be 21. So all of them, they'll actually give you 36. Okay, so in order for us to understand the relationship that exists between number of terms and sum of number of terms, let us remove these numbers for now. Okay, let me remain with variables only. So it means my S1 is equals to T1, and then my S2 is equals to T2 plus T2, my S3 is equals to T1 plus T2 plus T3, and then my S4 is equals to T1 plus T2 plus T3 plus T4. Okay, now let's check it. So if I was to look at S2 to be T1 plus T2, let's look at the relationship that exists. We know that T1 is equals to S1. Okay, check it. So S1 is equals to T1, which is the same as this one. Now, what can we do? We can actually say, instead of writing T1, we can actually substitute T1 with what? With S1. Then this will actually give me S2 is equals to S1 plus T2. Okay, this S1 that you see there is the same S1 that we're having here. So this S1 is the same as this S1, and this S1 is T1 plus T2, and T1 plus T2 is what? Is S2. Okay, now let's check. If we were having S3, look at S3. For the fact that we know that S2 is equals to T1 plus T2, which is this one and this one, it means instead of T1 plus T2, I can actually put S2. Okay, so this will actually give me S3 is equals to S2 plus T2, because my S2 is equals to T1 plus T2. It is here, it is clear. Then we can do the same for S4. Okay, so the S2 that you see there is the same S2 that is there. All right, so let's look at S4. When you look at S4, for the fact that we are actually having T1 plus T2 plus T3 to be S3, which is this one and this one. Now, it means instead of T1 plus T2 plus T3, I can easily substitute by S3, which will actually result in S4 is equals to S3 plus T4. S3, why? Because T1 plus T2 plus T3 is given to be S3. Okay, so instead of writing all these terms, I can easily substitute S3. Okay, now let's look at it. The S3 that you see here is the same S3 that is there. Okay, so this becomes very, very, very simple, because you look at the equations that we have actually generated here. These are SNTN variable equation. Okay, because you have a sum of number of terms and number of terms. That is why we are looking at the relationship that exists there. Now let's generalize. Let me put everything in perspective. Okay, so if we were to put the first term, we look at all of them. The first one, the second one, the third. So the third one and the fourth one. We agreed to say S, the sum of one term is the first term. Sum of two terms is S1 plus T2. Sum of three terms is equals to S2 plus T3. Sum of four terms is equals to S3 plus T4. Okay? Now, this will actually give us other equations. So it means if I want to determine the sum of two terms, I need to know the sum of one term, and then I need to know those number of terms. So if I know T2 and S1, I can determine S2. The same thing apply. If I know S4 and T4, I can determine S3. Now let's look at the relationship that exists here. If you want to determine the sum of number of terms, not knowing the first term, what you can actually do is every time it will be, if it is sum of two terms, it will be plus T2. If it is S3, it will be T3 plus T3. If it is S4, it will be plus T4. But what you must not make a mistake about is your S's on the right hand side will be one less than the previous one. Like now, if n is 2 here it will be 2 minus 1, which is 1. If n is 3, it will be 3 minus 1, it is 2. So it will always be 1 less. So it's S2 T2, S3 T3, S4 T4. But S2 S1, S3 S2, S4 S1. Okay, so from this relationship that we're actually having here, we can actually come up with a relation. This is when you want to determine the sum of number of terms. But what if you want to determine number of terms knowing the sum? Okay, so it means we can actually make T the subject of the formula, and then you will actually get T2 is equals to S2 minus S1. Okay, the same thing apply here. You can make T3 the subject of the formula, and what will you get? Obviously, doesn't need a metric brain. T3 is equals to S3 minus S2. Okay, and then likewise, it means T4 will be equals to S4 minus S3. But now, I want you to realize something. If you are to determine a number of terms, you need to know the sum of number of terms. So if I want T2, on the right hand side, the sum, the n will be the same. If it is T2, it will be S2. If it is T3, it will be S3. If it is T4, it will be S4. But instead of adding, you're going to subtract. You understand? You're going to subtract. And then what do you subtract? You subtract the sum of one less than number of terms. But in this case, what were you doing? You were having Sn minus 1. Okay. So for T2, it will be S2, T3, S3, T4, S4. Then you subtract Sn minus 1, Sn minus 1, S4 minus 1, which will be 3. Just like that. So it means when you want to determine number of terms, you need to know the sums. Okay? So the sums with a difference of 1. The sums with a difference of 1. The sums with a difference of 1. Just like that. But if you want to determine the sum, you must know number of terms and the sum. Number of terms and the sum. Okay? So it becomes very simple. So if we were to put all of them together, okay? The same one that we're talking about, if you say S1 is equals to T1, automatically it means you can still make T the subject of the formula, and then you have T1 is equals to S1. So now this was actually taken from S1 is equals to S2. So it means under general, or in summary, you can easily say in an arithmetic sequence, T1 is equals to sum of one term, T2 is equals to S2 minus S1, T3 is equals to sum of 3 terms minus sum of 2 terms, and then T4 is equals to sum of 4 terms minus sum of 3 terms. Okay, so it means we can actually come up with a general formula for this particular kind of a relationship. Okay, so this relationship that exists, that we have actually found, the relationship between Tn and Sn, it is actually given by all these things that you see here. Okay, so in summary, we can easily say, okay, Sn is equals to n minus 1 plus Tn. That is the first thing. Sn is equals to Sn minus 1 plus Tn. Or we can easily say Tn is equals to Sn minus 1. This is a relationship that exists. Please make sure you understand everything. And then if you don't understand, play the video over and over again, because this type of a question is frequently asked in the final examination. Okay, so this will mark the end of this lesson. Please, people, don't forget to subscribe, like, and share. Hit the notification button so that you are actually notified of future videos. Okay, thank you for watching. God bless.